Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 34 years, and today our topic is radio and radio waves. And before I do that, I have to explain about electromagnetic wave. And this is the logo I created. If you click this logo, you can watch all my 76 or 77 theories, and it says unique physics concepts science by Vahan Davudyan, how to promote the science. And this is my email, vahandavudyan1948@gmail.com. And today our topic is radio and radio waves, which is so important in physics. Then you can tell, when we're talking about electromagnetic wave. First of all, I have to mention James Clerk Maxwell, one of the greatest physicists, Scottish physicist and mathematician, who discovered in 1860 electromagnetic wave. As he was calculating, he realized that is exactly the speed of light. Then he just theorized that the light is electromagnetic. Well, of course, this was breakthrough in science because nobody knew that the light was electromagnetic. Then I will explain it later. And after him, there was another great scientist, German scientist, Heinrich Hertz. He came up and they discovered the radio waves. And then after that, we had the radio and everything else. But at that time, it was, tubes, and then we had the transistors and everything else, which was so important. But before I do that, so I have to explain this, that how important the electromagnetic waves are, because these radio waves are part of the starting of the electromagnetic wave. And amazingly, the wavelengths are so long. We can start from 100 kilometers all the way to 1 meter, but the frequencies are less. And then after this comes the microwave, which is microwave. And then after this comes the infrared, which is nanometer, 1 billionth of a second. Then comes to, visible light, which is also nanometers. And then all the way to X-ray and gamma rays. And you can see the proportionality. The more we squeeze this wavelength, the more powerful they become. So in other words, the stretching is always, is proportional to bunching up or, shrinking. It's impossible that, you can increase the wavelength and then naturally it comes weaker and weaker. And in fact, I have this, you can see this, how the electromagnetic waves works. Let me just put this on, and then I can explain that. This is what James Clerk Maxwell did, and in fact I have to mention this, how it works. When we have electric charges and then they create electric field, but the moving electric field is creating magnetic field. So what happened if we accelerate the charges and then up and down, they create electromagnetic waves. So in other words, electric and magnetic wave travel together at the speed of light, and this is the wavelength, and this is the magnetic field, the electric field, and you can see they're perpendicular to each other, and they traveled in vacuum, because there is nothing that can stop the electromagnetic waves. So this is the way they work. Then that's why we have the radio wave, we have the communication, and everything else. So this is the process. As you can see here, we have the microphone here. And whenever we accelerate the charges, as I mentioned a few minutes ago, they create electromagnetic waves. And this amazing electromagnetic waves can go all the way to Jupiter and beyond. Even, even radio waves come from outside solar system, beyond Kuiper belt, and, from different galaxies. So that's so important that we know what the radio waves are. Well, of course, later I will explain that we have the telescope and then we get those waves, and sometimes they come from so far away galaxies, and the human beings are not able to decipher what they are because it's so difficult anyway. So this is the way it works. When we have a wave, so it's captured by the microphone, then you can see the waves over here. But unfortunately, what happened, it is so weak. And these waves, just create a little bit current, very tiny current. And then what happened, that current is detected by diode and transistors. And then after that, we have this transmission then you can see those waves are, those magnetic wave, electromagnetic waves travel all the way to this, we get the radio waves. Well, of course, I have to explain a little bit about the, speakers. In the speakers, there is a coil, and then it doesn't matter how you send the electric current. I'm talking about DC current. So if you go one way, it comes down. If you go up, it goes up. So in other words, that fluctuation called, it creates the sound. And in fact, I have to do this one as well. You can see what the electromagnetic waves are. Radio waves are. And this was another genius. His name was Heinrich Hertz. And this was amazing. James Clerk Maxwell didn't do any experiment with the electromagnetic wave, but after he passed away, and in 1888, Heinrich Hertz, that's why, Hertz, famous said, this electricity is 60 hertz, that is in his name, Heinrich Hertz, and he was so genius. He set up this experiment, and you can see these two globes. They're copper, I think, and they were 1 meter from this, antenna, and you can see there's a small gap over here, and you can see the electromagnetic wave. And this was groundbreaking experiment. The way Mr. Heinrich Hertz did, he just changed our world. And then after that, we realized that the radio waves, they don't need any connection. Electromagnetic wave can travel in a vacuum, and you can see this little gap. I have no idea how big this gap was, but he had to put induction coils, put high power here. Then he realized between this gap there is a spark. Then this was so important, and this was breakthrough in science. And then he realized that the electromagnetic wave can travel in space without any connection. That's why we can talk to space station, we can talk to all the way to Jupiter and beyond solar system with all electromagnetic waves. And that was his, well, of course, I have a small thing from, this was in, when I was in college. I remember I printed this in 1976, and you can see this is the antenna, and then you can see the waves are coming in, and this is the capacitor, and then this is a diode, and this is another capacitor. So what happened, that diode is just discovering or detecting that thing. And then, well, of course, as I showed the transistor here, the transistors are enhancing or enlarging everything. So you can see it's amplifying everything. You can see it shows. And I remember this radio, I was maybe 6, 7 years old, and I remember we had this old radio, but I don't remember the vacuum tubes because this was in 1931. Well, of course, before the transistors, it was the vacuum tubes, and they were so hot, they were consuming a lot of electricity, and it was in 1931. But when I was born, and after a few years, transistor came, and these are the transistors, and they changed our world. And those two American scientists, John Bardeen and the Shockley and Brattain, they got Nobel Prize for this, which was amazing. And after transistor was born, and then our life was changed. I remember I bought a radio, 6 transistors, all day long I was listening to music. But nowadays the young generation don't even know what a transistor is, because all they have seen is the radio and this all IC. And now, those days, I remember we used to even fix these transistors. And that's how, this is another, telescope, like I said a few minutes ago. You can get outside even solar system from different galaxies, you can say. But the important thing is the humans should have that, technology to decipher what are those signals. Is this from extraterrestrial? Where does it come from? How does it mean? We are not there yet because we are still working on it. And I remember let's see, where is it? I remember in Boulder University, let me put this on. This is so important. I want you to pay attention how important this experiment is. I was explaining electromagnetic wave, and in fact, this topic was about Doppler shift, which is red shift and blue shift, but the concept is the same. I had to came up with this idea. So this is the extension spring, and you can see when the car is passing, is coming close, the pitches are so high. When it's going away, it's less. But you can see here something important. And the university professors and everyone like this idea because this is my invention. You can see while I'm stretching over here, they're getting bunched up. So stretching is directly proportional to shrinking. See, you can see here, electromagnetic are like that. The reason why we get the electromagnetic wave, because always the proportionality is always saved. It doesn't matter how much you stretch it. On the other hand, it's going to be shrinking. It doesn't matter how much you shrink it, this side is going to be stretched. See, there is no way that can be otherwise. But you know what? This is simultaneously. It just happened immediately. We have no idea how that happened, but this is the main advantage of the electromagnetic wave. And then you can see here, this is called, Doppler, and he was genius. He was so genius, Austrian physicist. And then he was sitting in Austria, in Vienna, watching a big, truck came in where people were, playing trumpet and playing, so much music. And immediately, because he was so good, he realized once that, truck is coming toward him, the pitch is so different. When they go away, it's getting stretched. And then he came up with this idea, Doppler. And this is the way we discovered so many planets outside solar system, billions of light year away. It's because of Mr. Christian Doppler. So we call it blue shift and red shift. You can see here it bunch up, and here is a stretch. And this man is perceiving different, and this man over here is perceiving different, because they're going toward him, but they're going away from this man. So that's so important, the radio wave, how important in our life is, and I'm hoping you guys love it, because I had to, just make sure I bring up the basics, not to talk a lot, because sometimes, most people watch it, they don't want this more than half an hour or something like that. And I'm hoping that you guys will love it. If you love it, you can go ahead and subscribe it. And then I was not, in good shape for 2-3 months, so I didn't have any theories. And I'm hoping that this will be so effective because it's electromagnetic wave, and hopefully you would love it and you can subscribe it. Thanks a lot for watching, and always, I admire your ideas. Always, I honor your ideas. If you can email me, I always put it in action, because I know the way I can improve my theories is by listening to listeners, listening to people, enthusiasts like you guys. So hopefully we can improve this as much as we can. Thanks a lot for watching.